Hello everybody, welcome to this tutorial. We'll be discussing graphics in R. We'll look at several commonly used graphics functions in R, and then we'll look at the options for customizing graphics. First, before we start with actual examples, we're going to read in a set of data for all of the rest of our examples. And let me just quickly show you the shape of this data. Basically, I have a list of people, and every person is described in these 9 attributes. And I've already have this file saved in my current working directory as a comma-separated variable file. So the file basically is in this format. Every value here is a scalar value describing this particular attribute for this particular person. Let's first read in this data set using the command read.csv. As you can see that my data file has the first line as the headers, so I specified this header option to be true. And let's take a look at all these variables written in this variable watch. As we can see, all of these values are in here. We can also take a look at the summary of this data set by using the summary function. Basically, we can see all of these 9 attributes and the min, max, first quantile, third quantile, medium, and all these informations being described here. Now let's get to our main topic, which is plotting. Plot is the main function that does this in R. And the plot function automatically produces simple plots for vectors or data frames. And there are many useful customization options. Let's take a look at our first example. Basically, we've already created this data set, and for weight, that corresponds to the third column of my data. I just plot this vector. So we can see on this plot panel, I have this diagram created. On the x-axis, it's the index, so it just goes up for each data point. On the y-axis are the values in this vector. And if we were to take a look at the size of this vector, it's 252 data points, so that's the number of dots on this diagram here. Let's see, we can also sort this vector by calling the sort function, and then plot the sorted version of the same data. So this is what we see. And we are going to use several options that place some descriptive text on this diagram, so we can show the informations that we would like to show. I'm going to discuss main gives a title for the diagram, and then XLAB and YLAB are going to place the labels for x-axis and y-axis. Here, those are the strings that we gave. Okay, now we're going to talk about the options to specify a range of the axis. These are, you can think of them as zoom in and zoom out on the plot. So basically what I've done here is a zoom in. I specified the limits for x-axis is from 50 to 200, and y-axis is from 70 to 100. And this is the diagram that I got from the plot. Okay, so now we are done with the one vector getting plotted. We can also specify 2 vectors that are plotted against each other. For example, here we have all 9 different columns, different attributes describing a person. How about let's plot weight against height? So if I plot weight against height, I get a diagram in this way, and we can see there are 2 pretty obvious outliers in this data set. And I specified the labels as well so that it's not confusing of which is which. Okay, let's talk about two other options that basically used for the appearance of the diagram. We can use different types of marker and specify a color for it. PCH is the option that you can specify different types of markers, and this is useful when you have a scatter plot of all different data sequences series, so you would like to separate them. Color is also useful in this way. So for color, you can specify them in this way, or there is a predefined list of color, and you can just type blue as well. It does the same thing. Okay, before we move on to our next type of diagram, let's look at a way of plotting multiple charts on the. For us, we have a data set of all 9 attributes, and we're going to plot this data set and then provide a vector for the second, which is the height, and third, which is the weight, and fourth and fifth. And this is what we got. So basically we get a pairwise scatter plot for all of these attributes, and we can see these ones that are shaped this way we can tell that they have a strong correlation. Yes. Now we are going to move on to the next type of plots, histograms. Before I do that, let me use Control L to clear the console here, and we'll keep this data set because we'll be using the same data set for all of the examples being discussed later on. Let me clear this plot window as well. So histogram, basically we are talking about the hist function, and this is what we will be using. One particular parameter option for this function is very important, that is breaks. Basically that can specify the number of categories to plot, or specify the breakpoints for each category. Let's use the same vector of data that we used for the previous example, which is weight, and then we just call hist on it. We see a histogram in the plot panel. Let's experiment with the breaks option. Let's say if we have the same data series, and then we're going to use breaks for a sequence starting at 40, ends at 180 with a step size of 5. Let's take a look at this one. So basically we have a finer plot, and the other type of breaks is just a scalar value, which does a similar thing. And we have all of the previous options such as XLAB, YLAB, and the limit. All of those are going to be the same. So let's look at an example. So we can still specify the title of the plot and the labels on the XY axis. Finally, for example, if we look at this, sometimes it would be helpful to have extra piece of information on the diagram. For example, if we are also interested in where the say this is a normal distribution, we're interested in where the mean is, we can plot on the same diagram a vertical line. So I'm just going to call this ABLINE function, giving it V as the option for being vertical, and the value is mean of the data set for the average of everybody's weight, and then I color it red. So this is a marker of where the mean is for this data set, and that is histogram. Also, as you notice on the y-axis, we are looking at the absolute counts for each bucket. And sometimes we're also interested in the density. So that is specified with the frequency argument. Let's take a look at an example and then discuss this example. This frequency argument over here is default to true. And when it is true, the histogram is a representation of frequencies, the count of the result. If it's false, which is what it is here, the histogram is a representation of the probability density. So you can see that the y-axis has changed in unit. Basically, the area size of this histogram with the frequency option to be false is going to be 1 to be the area size.